the Cretaceous period. For the first time in history, the landscape would have been dotted with the colour of the very first flowers. These flowers would have been attracting a variety of new pollinating insects. First came the bees, but then came another famous insect, butterflies. Butterflies and their moth cousins are part of a giant group of insects called Lepidoptera, that means scaled insect, because both butterflies and moths are covered in tiny scales. These scales are highly adapted hairs that contain coloured pigment, and are what allows these creatures to have their defining feature, their brightly coloured and elaborately patterned wings. These scales do have other purposes, like sometimes helping with temperature regulation, but they are primarily for display. And a lot of what made butterflies and moths successful is owed to the vivid colours that these scales emit, either using them to confuse predators, to disguise themselves as another animal, camouflage, or to attract a mate. And fossils of these scales can be found in the same rocks as dinosaurs, only they were most likely not left by butterflies, but moths, as moths are actually considerably more ancient than butterflies. So moths have almost certainly used their patterns as a predator deterrent for many millions of years, and would have used them to confuse and escape ancient predators that they once shared the skies with, maybe even insectivorous pterosaurs. Moths came first, and butterflies evolved from moths, and are technically just another group of moths that are active during the day, or diurnal. There are some moth species that are diurnal as well, but this is a recent change. Butterflies descend from a lineage of moths that started being more active during the day millions of years ago, and have adapted to this lifestyle, which is what gives them their distinctive butterfly features. It was thought that butterflies evolved from moths in the Eocene epoch, around 40 to 50 million years ago, because this is when the first butterfly fossils start to appear in the fossil record, most of which are known from the fluorescent fossil beds in Colorado, famous for well-preserved insect fossils. Just a few million years before this, the most feared predator of moths first evolved, the bats, and a fierce evolutionary battle between moths and bats has been waged ever since. Bats evolved sonar, and in response to this, moths developed ears to hear the sonar, and deploy evasive flight maneuvers to avoid being eaten. Or they adapted special modified scales that absorb sonar, making it harder for the bats to see them. And it is thought that one group of moths escaped this deadly arm race by switching the schedule to the daytime, becoming butterflies. However, this is no longer thought to be the case, because it is unlikely that bats evolving would cause any more danger to moths that butterflies don't equally face from insectivorous birds in the day. And more importantly, a DNA analysis in 2019 shows that butterflies actually branched away from moths and became diurnal about 100 million years ago in the mid-Cretaceous, long before bats ever took flight. It is now thought that the group of moths that would become butterflies actually started to come out during the day to take advantage of the new food source that had evolved in the Cretaceous about 130 million years ago: flowers. Most flowers close up at night, and so aren't readily available to nocturnal insects. So by switching their schedules, they were able to take better advantage of the nectar of the flowering plants. Bees evolved about 120 million years ago, and the symbiotic relationship between bees and flowers is probably what drove the diversity of colours that flowers have to attract the bees. 20 million years later, butterflies copied them, joining them in coming out in the day and taking advantage of this new colourful world. And their diurnal lifestyle is what shaped them and made them distinct from other moths. Although there are many beautifully patterned moths, their colours tend to be fairly drab, because colours aren't very clear at night, so being brightly coloured would just go to waste. But once butterflies started being active during the day, they shook the browns and greys of their moth cousins for a new rich variety of bright colours, useful for attracting a mate. In turn, the eyesight of butterflies changed to become much better at seeing colour, and now primarily locate a mate visually, whereas moths usually locate mates using pheromones. And some of the colours that butterflies use to signal to mates are not even visible to us, because they can see in ultraviolet light. The bright colors also sometimes serve as warnings of toxicity to potential predators, whereas moths primarily use their colors for camouflage while they are resting during the day, although there is some crossover between the groups. Interestingly, the same study showing that butterflies branched away from moths also calls into questions other things about Lepidoptera and evolution. It has long been thought that moths evolved ears so that they could hear bats coming from them. But this study shows that moth ears predated bats by quite a large margin as well, and have evolved multiple times. So they would have already had ears when bats first started hunting them, and just adapted them to become more specialized for hearing sonar. So their ears may have originally evolved for hearing birds or perhaps even insectivorous pterosaurs. So bats seem to have been a much less important driving force in the evolution of lepidopterans than previously realized. Although butterflies evolved from moths in the late Cretaceous, lepidopterans have much more ancient origins. Their closest relatives are caddisflies, and DNA evidence shows that these two groups of insects must have shared a common ancestor somewhere between 300 to 250 million years ago in the Permian period. But the mystery is that although caddisflies have a really good fossil record dating all the way back to this time, the fossil record for moths and butterflies is really patchy. Some of the earliest Lepidopteran fossils are known from the Jurassic period, but these moths wouldn't have been that familiar to us today because they were considerably more primitive. They looked a lot like caddisflies and other flying insects than moths, and instead of their tube-shaped proboscis, they had jaws or mandibles. We take it for granted today that moths and butterflies just have a proboscis, and to be fair, about 99% of Lepidoptera species have them today, but there are some really primitive members of the group that don't, and instead have jaws, like other insects. The most primitive group of living moths are called the Micropterichidae. These moths are living fossils and are survivors from an early branching in the Lepidopteran family tree before they evolved proboscises, and shows what moths would have looked like millions of years ago in the Jurassic period. The jawed moths would have been a lot more common once, but have now been sidelined by the more modern moths, and it was thought that moths and butterflies first evolved a proboscis in response to flowers. But recent discoveries have pushed this considerably further back in time, and shown that moths developed their mouthparts before flowers had evolved. Fossilized insect remains have recently been found in Germany dating to around 200 million years ago in the late Triassic period, and among them are the very distinctive scales of Lepidopterans. But what makes this discovery more interesting is that these moth scales belong to animals that would have had a proboscis, even though they were living as much as 70 million years before flowers had evolved. Although butterflies mainly eat flowers, moths actually get their liquid food from a few different sources. Many moths use their proboscis for other things, like sucking liquids from animal dung or other sugary liquid sources, and rather poetically, one species of moth even uses its proboscis to drink the tears of sleeping birds. It was originally thought that moths that used their proboscis for other things than flowers had evolved from nectar-eating Lepidopterans, but these new fossils show that it actually happened the other way round, and this may be why Lepidopteran fossils became increasingly more common in the Cretaceous. With their proboscis, they were perfect for taking advantage of this new food source, and became a lot more successful while doing so. So a lot of new discoveries have shifted what is known about the story of butterfly evolution, and some parts of it may still remain a mystery or uncertain. But what is certain is that the vibrant colours of butterflies and the flowers that attract them certainly add immensely to the beauty of the planet.